3, 2.
Hello, everybody, and thank you very much for joining us on this misty, foggy, rainy Tuesday evening for our monthly webinar. I'm hugely pleased to welcome Afandi Darlington, a senior investigator at AAIB, along to give us a talk tonight. Before we move on to what Afandi's got to say, which will be significantly more interesting than what I've got to say, a couple of housekeeping type things. First of all, if there are any questions that you have during the presentation, pop them in the questions, and if I kind of think they're appropriate to the stuff that Andy's talking about at the moment, Afandi is talking about at the moment, I'll ping those up on screen. If, however, excuse me, if, however, they're of a more general nature, I'll star them and come back to them later, and we'll kind of address them later in a whole thing. So that's how that's planning to work. Hopefully, I'll manage that one. Just do me a big favor, please. If you get a chance, like this on YouTube, subscribe to our YouTube channel. That costs nothing. That would be absolutely brilliant. And tonight's webinar, this is normally a members only webinar that goes out. We have one of these every month on a whole range of fascinating subjects. This one is we've decided to make completely public. So if you're not a member, this is a kind of a special insight into the kind of thing that we do every month. So please consider becoming a member. You can become a member for just £5 or even £3 a month. We'll go to flyer.co.uk/membership. And if you use the code SUMMERSAVER over the next 3 months, you'll save yourself £1 for the first 3 months. Almost so £4 or £2. So jump on there for us. That would be great. I think that's enough of me talking before I lose my voice anyway. So, Afandi, welcome. Thank you very, very much. I'm just going to pop your slideshow up on screen.
Thanks, Ian. Thank you.
If you're ready, I'm going to take myself off, mute myself. I'll be in the background. I'll change the slides for you. If you got any problems, questions, give me a shout, and I'll see you later.
All right, great. Thanks a lot.
Thank you.
Well, good evening, everybody. My name is Afandi Darlington. I'm a senior inspector of air accidents at the AAIB, and it's my pleasure to give you a talk tonight about the work of the AAIB Air Accidents Investigation Branch. And I'll describe a little bit how we respond to general aviation accidents, give you some stats on the activity last year and how that compares to previous years. I've got some data on age profile of UK pilots, which I think might be hopefully interesting to you all. And then following on from that, I'll dive into the stuff which was in our recent annual safety review article which I wrote on general aviation safety statistics in terms of fatal accident rates and mid-air collision statistics. Take questions as we go and at the end. And channeling Chris Whitty, I'm going to be getting Ian to advance the slides. So next slide, please. Okay, just a bit of background on who I am. So I'm an aeronautical engineer. I did a degree in the early 90s in aeronautical engineering. I also have an MSc in safety and accident investigation from Cranfield, which I did after I joined the branch. But after my degree, I worked as an aeronautical engineer for 15 years. Initially at Airbus in the aerodynamics team at Filton on the wing design for the A340-600 and then the A380. And then I left to go and join a crazy startup company called Farnborough Aircraft doing a single engine turboprop, which is the aircraft on the bottom right of the image, called the F1 Kestrel. And I was on that project for 9 years, and I was technical director and chief engineer, leading a very talented team on that aircraft. In 2010, I joined the branch as an engineering inspector. I'm crazy about flying. I've been a glider pilot since I was 16, and I hold a PPL with a TMG rating, and also turn wrenches for the BGA as a senior inspector in my part-time spare time. Next slide, please. All right, so I guess quite a few of the audience have heard of the AAIB, and maybe you've had the good chance to come for a tour around the branch at Farnborough, which is always hopefully of interest. So the AAIB is a part of the Department for Transport, so we're part of central government, and we are there solely to improve aviation safety by determining the causes and circumstances of aircraft accidents and also serious incidents, and I'll describe those later, and promoting where we can safety action intended to prevent recurrence. And then we do that by looking, after something's gone wrong, an accident or an incident, what exactly has happened, how has it come about, and why. And we do that through collecting evidence as diligently as we can, analysing the evidence to try and draw some conclusions out, and then following on from that, influencing safety through safety actions with the industry or the operator, or if we still think there's a safety deficiency, we'll make a safety recommendation. Under our UK legislation and international law, we are duty bound by law not to apportion any blame or liability in our reports, and our reports are anonymised. They don't contain anybody's name. If a crime has been committed, or the police believe a crime has been committed, or a terrorist incident, obviously the police are involved, and we have an MOU with the police on how exactly that works. Basically, they share access to factual evidence like wreckage and things like that, but that's as far as it goes. All our witness interviews and everything else, like statements, etc., are protected by law. And colleagues from the CAA, if they believe that there's been a breach of the regulations, they can also carry out a parallel investigation against, completely independent from ourselves. Next slide. And so the history of the branch is quite interesting. It's over 100 years old as a sort of function within the government. It started, well, the first Inspector of Air Accidents was appointed in 1915. And that was within the Royal Flying Corps when they realised they were losing more aircraft to accidents than they were to enemy action. So they thought it'd be a good idea to do some accident investigation. So it started within the Royal Flying Corps, but as soon as World War I finished, that function then became part of the Department for Civil Aviation within the Air Ministry, and it's resided essentially in that same part of government ever since 2002, being part of the Department for Transport. Very important, we are completely functionally and geographically independent of the CAA. The CAA is a regulator, and we are the Accident Investigation Authority. So they're two very separate functions, but both fall underneath the Department for Transport for their governance and funding. And just to show there's not much new in aviation, there's a picture at the top there of a biplane on its nose after an accident. And the picture in the bottom right is more recent, 2020 at Sywell. That was a BE-2C replica accident. And perhaps the only difference in 100 years or so is health and safety legislation. You can see that the wreckage is a bit more stable, propped up with a ladder, 2020. But there's not much new in aviation. Perhaps that's changing. Next slide, please. And it's not just biplanes. So we are under our regulations required to investigate reportable accidents to commercial air transport, general aviation, heavy helicopters, warbirds, balloons, unmanned aerial systems, you name it. If it flies and it's got the potential to injure someone, then if there's an accident, it will fall under our regulations, and that now includes space as well. From about 2 years ago, our regs were extended to include space launch, and that's not just the Virgin Orbit aircraft there, which did a launch out of Cornwall a couple of years ago, but also all the vertical launch activities in Scotland as well. So it's very wide ranging. Next slide, please. So as said, we are part of DFT. This is our structure. So we have Chief Inspector of Accidents, that's Crispin Orr. We have a Deputy Chief, and then 6 Principal Inspectors, who are basically the group leaders for the specialist skills in the branch. And beneath them, we have 29 inspectors. So I'm one of the engineering inspectors, one of 10. Correction, one of 12 engineering inspectors. We have operations inspectors, human factors inspectors, and recorded data inspectors. And I'll give you a bit more information about those in a minute. But very importantly, we have excellent support from admin support and engineering support within the branch to allow us to go out and do our investigations with all the help we need. And the principal inspectors, they are responsible for determining the response of the branch in the case of an accident. So that's a role called duty coordinators. So they'll decide what sort of team's going out and how many people, etc., to any particular event. And they also are the investigators in charge, which is like the project manager for any investigation. Okay, next slide, please, Ian. So just a bit more on the disciplines. Operations inspectors, we currently have allocation for 10. We're looking to recruit 2 at the moment. So if keep your eyes peeled for job adverts if you meet the requirements for that and are interested. But they are professional pilots, either fixed wing or rotary, or both, but usually one or the other. They maintain their ATPLs. They fly with selected operators once or twice a month to maintain currency and keep their industry knowledge up to date. And their job in an accident is to, it's the people side of it. So it's all about the crew, witnesses, liaising with the next of kin if it's a fatal accident, or survivors, etc. And then all of the operational matters, so air traffic, weather, training, all the operational matters. Engineers like me, we have either a civil or a military background. We've got a mix of backgrounds in the branch. Obviously, I'm a civilian background person, so a good mix of skills amongst our engineers. We all have engineering degrees, and most of us are chartered as well. And we have a very broad background. That's what we need as engineers, is not to be specialists, but to be generalists. And our job is to go out to the scene of an accident, investigate the physical evidence, the wreckage, and any technical aspects of the accident which may be relevant in terms of airworthiness issues, things like that. We'll recover the wreckage back to Farnborough, maybe do some more forensic investigations at Farnborough, and just follow the evidence, see where it goes. It may be a maintenance error, it may be a fatigue crack, or it just may be absolutely nothing wrong with the aircraft and it's an operational issue. But we have to hunt through everything to eliminate what we can. Recorded data engineers, they are similar to the engineers in their background. They have a degree, but typically more in the avionics sort of area of expertise, data or avionics. We've got people ex British Airways, Flight Recorder Department, Airbus, systems engineers, etc. But with a sort of data bend, and they are basically anything with data on is their business. So flight data recorder, cockpit voice recorder, CCTV, data which is up in the cloud, perhaps has been streamed from an aircraft, radar data, etc., etc. Devices, iPhones, GoPros, that's their métier. And it's incredible the work that they can do in terms of getting data off devices which have been burned or damaged, and you think there's no way they get any information from that, and it actually is the key to unpicking the accident. And last but certainly not least, we have one human factors specialist, Tony Flint. She has a degree in psychology, and she is the branch resource for human factors. We're all HF trained as inspectors, but not anywhere near the level that she has. So that's who we are. Next slide, please. In terms of the legislation, so legal powers and things, we operate under a set of international standards and recommended practices, which are part of ICAO. So 1944, there was a Chicago Convention. 52 states, I think, got together and set out the rules of international civil aviation for after World War II, and all the rules are set down in different annexes. And someone had a sense of humour because Annex 13 is the accident one. So Annex 13, standard recommended practices, are what nations who are signatories to ICAO, which is most nations around the world, have to live up to, and that flows through EU law. So we've got EU retained Regulation 996, which is still in our statute as retained EU law, and then there's a UK statutory instrument, which is the 2018 regulations. So those are the sort of legal documents which allow us to do our work. Next slide, please. What's our remit? Well, it's the top of the accident pyramid. So you know, an accident's the tip of an iceberg, and below that there are serious near misses, serious incidents, if you like, and below that incidents, and then normality at the bottom, with the number of events going up as we go down that pyramid. So the AAIB is obviously respond to accidents, reportable accidents, and also serious incidents for commercial air transport. And I should mention at this stage that whilst we're talking here about general aviation, one of the main functions of the branch is really to keep the travelling public safe on commercial transport, or people going to work on commercial transport flights, the North Sea helicopters, things like that. So this lecture is sort of GA heavy, but you know, a very major part of our work is keeping you safe when you're on an airline, or as part of that whole safety system in commercial aviation. You know, so that's why we do serious incident investigations on commercial air transport, because thankfully there are so few accidents these days. So below our remit as the branch, we have the regulator with the MOR system. So mandatory occurrence reports, which are incidents, so not an accident but an incident, and there are about, I think, 30,000 of those a year that the CAA collect. So that really informs them as regulators about where to focus their efforts in terms of safety. And then below incidents, we have basically normal operations or things perhaps have gone slightly wrong, and that's where the operators might look at that with their flight data monitoring systems. To just improve the operational performance or safety level of an operation. We work closely with the sporting associations, the BGA, the BMAA, the LAA, NATS for radar data, and obviously the manufacturers for technical issues regarding their products, the insurance community, and obviously the operators. And as I mentioned before, we have a certain interface with the police, health and safety executive and the CAA enforcement branch, but only very limited and strictly controlled by agreements between ourselves and those agencies. There was a question there in that popped up. I don't know if you want to let that pop in now. So, is the forensics done on site? Do you have your own lab with electron microscopes, NDT equipment, or do you work through partner universities? That's a great question. Most forensics isn't done on site. Perhaps things like sample taking, obviously take huge amounts of photos, and you have drones and things to record accident sites. But in terms of the forensics, which is lab type stuff, we have obviously a flight data recorder lab, which is world class. And chip level recovery for damaged chips, etc. But for broken bits of metal, we'll typically work with agencies like Kinetic. So we have a standing contract with Kinetic where we can take stuff to their failure in that lab just over the runway here at Farnborough and get it looked at pretty quickly. And also some universities for things like CT, X-ray, tomography, and other specialist chemical labs and things too. So yeah, but we're a little bit different than other agencies around the world. Some of the bigger ones have their own labs in-house. We're a bit small to actually justify that, so we use outside agencies. Next slide, please. So what's a reportable accident? When should you ring the branch? So under the regs, it's defined as an occurrence associated with the operation of an aircraft, which takes place by the time from the time anyone gets on board that airplane with the intention of flight until such time that the persons have got off again at the other end, during which someone is killed or seriously injured, or the aircraft goes missing. MH370 is a good example of that, or is completely inaccessible, or the aircraft incurs significant damage, structural damage or structural failure. And just to get this right, I just had a look at our regs earlier on today. So significant damage is damage which adversely affects the structural strength of an aircraft or its performance or flight characteristics, or it would require a replacement of a major component which is affected in an incident. So things like if you taxi a 172 into a hangar door and take the wing off, that's a reportable accident. But there is a sort of lower threshold to that. So what is in fact not reportable is a single engine failure. So if you had one engine fail on an airplane and then did a forced landing and there was no other damage, that actually wouldn't be reportable. If you're not sure, please do report everything, but that actually falls outside the regs. Prop strikes, damage to wingtips, wingtip lights, antennae, spats, brakes, a flat tire, small dents or holes in the airframe are actually not reportable. But sometimes it is a bit of a grey area, so we do say if in doubt, just report it. Next slide, please. And so serious incidents. So serious incident, basically, all the elements were there for an accident, but providence meant that the accident didn't quite take place. So safety was impaired, and the only difference between an accident and serious incident lies in the end result. And so with commercial aviation, that's really our bread and butter these days, because thankfully the safety level is such that commercial air transport accidents are very rare in proportion to the hours flown. So quite a lot of our work is reporting on serious incidents, and one example of that's quite a good one. If you go onto the AAIB website and look up the registration Charlie Foxtrot Whiskey Golf Hotel, it was a 737 that took off out of Belfast back in 2017 with low thrust set. I think it was a data entry error into the FMS, and the crew set the wrong thrust, and the safety checks didn't work to capture that error. And the aircraft took off, and it took out the runway end lights, and 500 meters from the end of the runway, the aircraft was still at 40 feet, just 40 feet above the airfield level. And a mile away, it was only at 220 feet. So that is about the best example of a serious incident I can give you. And so that was investigated as if the accident had occurred. And serious incidents generally make quite good accident investigations because no one got hurt. The aircraft is fine. Generally, it's not damaged, and everyone's keen to learn as much as possible from the event. So they actually make quite good investigations. We don't do serious incident investigations for general aviation. We're not staffed to do that. That would be a huge number of investigations. So it's only for the commercial events. Generally, the odd exception, I did a battery fire investigation last year for a Icarus C-42, which actually was a serious incident because the aircraft wasn't damaged, but that's very unusual. Okay, next slide, please. So what's our response to general aviation events? At the bottom end, if the airplane is damaged, so it meets reportable damage, we'll generally send the pilots a form. This is the Aircraft Accident Report Form, or the ARF, as it's known internally here. And that's a 6-page form. It asks you lots of questions. It's just a data gathering exercise. I apologize for the length of that form, because sometimes if you're filling it in, you might think, why is this relevant? But we do need to capture the information. And so that the pilot will get that form, and it will come back to an inspector, and then it will be the response will be decided. More often than not, it's just a record only. So it might be just 1 or 2 lines in the bulletin saying Cessna 152 had a nose landing gear collapse on landing due to the pilot doing a PIO or something like that, where the safety benefits of doing an investigation aren't really very high. We can't influence that level of safety much by spending our resources doing it. This case that we're looking at here is a Glasair 2 RG. Good reg, whoever owns that aeroplane. And that was a forced landing following a fuel starvation. So there's fuel on board, it just wasn't in the right tank. The engine stopped and the pilot landed in a field, and unfortunately went through a fence. But he was unhurt. The airplane was a little bit damaged, and we'll write that. I wrote that up as a short report in our bulletin. Next slide. Moving up the scale, so fatal general aviation accidents to GA aircraft. In this case, it was an AA5 at Teesside. Microlights balloons. So sadly, someone or more than one person's lost their life. So we will always send a team out to do a field investigation, literally to a field quite often. And that team is normally 1 operations inspector, 1 recorded data inspector, and 1 engineer like me, plus our engineering support team of 1 or 2 people, depending on the scale. The investigator in charge usually remain back at the branch, won't travel for this type of event. And this one, I don't know if you remember, this was a few years ago now. It was a partial loss of power on takeoff at Teesside and a attempted turn back, which turned into a stall spin with very serious injuries to all 3 occupants, GBBSA. Yeah, so that's our response to a fatal accident. Typically be out the office doing our work for 3 or 4 days, or longer depending, but that's fairly typical. And then we'll come back, bring the airplane back, and continue the investigation back at Farnborough. Next slide, please. And then major accident response. So quick quiz, can anyone who knows which accident this is just type in into the question bar, see who gets there first. It's not a recent accident, but it's certainly a major accident. I can't see any comments. It's actually, oh, there we go. Yeah, Annabelle got it right. Kegworth. Yeah, this is the British Midlands 737 accident at Kegworth. Yeah, back in, I think, 1989, I think it was, before I started. Major loss of life, obviously a huge accident. So for a major accident, we have a major accident response, which is basically we send about half the branch to go and take part in the investigation. We send the chief, we'll send an investigator in charge, a deputy investigator in charge, about a team of about 7 or 8 inspectors, and the whole support team around them to set up a mobile command center to interface with all the agencies on site, police, maybe counter-terrorism, operators, manufacturers, etc. These big accidents are major undertakings under the international rules. So in this case, it was a Boeing aircraft with GE stroke Safran CFM engines. So Boeing will send a team under the oversight of the NTSB. So probably, I would think, 6 to 8 people from the US at an accident like this. There'd be a team from the engine manufacturer. There may be a team from other systems and equipment manufacturer if it's relevant. And obviously the operator, in this case it's a UK operator, but it could be a foreign operator or a foreign aircraft registry. So each of those parties has the right to participate, and you can end up in a room with sort of 60 people in it, and it can be quite difficult to manage. And obviously the recovery of that aircraft off the M1 is a major exercise in its own right. So we'd imagine if I got deployed to that, I wouldn't expect to be home for maybe 3 weeks. So that's the major accident response. Okay, next slide, please. In terms of our reports, you've probably seen these. The monthly bulletin, which is still printed. Long may that continue, personal opinion. I love seeing dog-eared copies of AAIB bulletins on coffee stained in a flying club, because it means people are reading them and hopefully getting some value out of them. It's obviously all published online as well, but there's still print copies available. So that's our monthly product. In terms of major investigations, they get their own formal reports. That's called a yellow, because it's got a yellow cover. So accident like GVSKP, the AW169 accident at Leicester City, that's a formal investigation, and it has a standalone report. We have special bulletins, so if we're doing an investigation and we need to get an urgent safety message out, we can't wait 9 months to get the final report out. We'll issue a special, which is a yellow top there at the bottom, and that may contain safety recommendations or safety actions which have been taken by manufacturer very early on when we have worked out that something needs to be done quickly. Excuse me. And then at the bottom right is our annual safety review. So that's the green top, and that's published annually, and I'll mention that a little bit later on. Next slide, please. So stats in 2023, there's a few years worth of data here, but I'll just talk about 2023. We had 719 notifications. So the phone rang here or with the duty office outside hours, almost 800 times, and slightly less than half of that was non-reportable or no further action. So it's perhaps an incident which has been graded as not a serious incident with an airliner, something like that. So that's good. That means we're getting lots of reports, and that's absolutely fine. Most of half of them roughly are no further action. But there were 25 field investigations. Those are GA fatals or commercial air transport serious incidents. We had 80 correspondence investigations, and you can see there the sort of growth in the recorded only. So that started in 2019, and then last year we did almost 160 of those. So sort of 2-to-1 ratio of correspondence investigations to record onlys, and then almost 50, that's 48 there, foreign investigations. So those are could be something like a UK manufactured aircraft or an engine, Rolls-Royce engines, which is involved in an event overseas, and an overseas agency launches an investigation. We will assign an inspector to take part in that and interface between the manufacturer and the overseas investigation agency to make sure the UK is fully immersed in that investigation. So that's one a week. That's actually can be a lot of work, those overseas investigations. I'll talk about the stats, fatal accident stats, in a little bit rather than dwelling on them now. So next slide, please. Right, ages. So I nicked a couple of slides here from my colleague David Wigglesworth because I thought quite interesting. So what he's got here is the ages of pilots who have been involved in accidents and reported on by the AAIB from 2016 to 2020. So if we took 2020, there were 83 accident reports that year. The youngest pilot was 23, the oldest was 91, and the average was 60. And 84% of the pilots involved were over 50. So as a GA community, we are middle-aged or older on average. And the trend over the 5-year period, the average age has gone from 57 up to 60. So we're middle-aged or older, and as a population of people having accidents, we're getting older. So that's really the point to make from that. Next slide, please. And I thought this was interesting. So this is the age distribution of general aviation pilots. So non-commercial license holders in the UK. It's the age distribution against the number of pilots. And there's 3 years worth of data here. So the light blue line is 2000, where the average age was about 44. And if you integrate under that curve, you'll also see that the number of pilots is higher than the other 2 years as well. So it's a sort of declining pilot population. But the average age 23 years ago, was about 44. In 2011, that had increased to 47 and a bit. And in 2018, that's 7 years later, it had gone up. So almost 5 years. So the average age is now 52, and it's probably gone up since then. So as a population of general aviation pilots, we are old-ish anyway, or old and getting older. So there's not enough fresh blood coming in at the left-hand side of that curve. Yeah, I thought that was interesting. I hope that's of interest to you. Next slide. Okay, so we're moving on now to sort of some of the analysis that was included in our annual safety review. Some of this work really came about from looking at mid-air collision statistics, but then we decided to expand it a bit. And that mid-air collision work was off the back of a gliding fatal mid-air collision, which happened last year at Melton Mowbray. So just to set the scene, this is 21 years worth of GA fatal accident statistics. So all we've got here are the number of accidents per year, sadly the number of fatalities involved, and a rate. And I won't concentrate on the rate here, but just in rough numbers, last year 10 fatal accidents, general aviation accidents. That was the same number of accidents that we had in 2003. The highest number per year in that period is 21 in 1 year. And the lowest number was during COVID, where we had 4 in 2020. So these are general aviation accidents. The aircraft weights involved are less, I think it's less than 5.7 tons, and it's non-commercial. So excludes, G-Red-L was a North Sea helicopter, that Puma accident. Excludes that, but it includes a police helicopter accident, and it includes the Shoreham Hunter. So if we move, next slide please, Ian. So to get to a rate, we need flying hours, and I have to thank colleagues at the CAA Safety Intelligence Data Unit who helped put these data together. So this was really looking more at the mid-air collision side of it, but we had to get the number of flying hours per year for the general aviation fleet. And so that was number crunched and provided to us. And when I plotted it out, this is the curve that I got. I was quite shocked by this until I sort of thought a bit more deeply about it. But 20 years ago, we were basically doing twice the amount of general aviation flying in the UK than we are now. So that's a major reduction over 20 years, from about 1.5 million hours a year down to something like slightly less than 800,000. There is a dip over COVID and a bit of a rebound, but the downward trend is, I think, fairly obvious there. So now we've got the hours, we can go to a rate. So next slide, please, Ian. So this is what the rate data looks like. So the blue solid line is just simply the number of fatal accidents in any one year divided by the number of flying hours in that year. And because the numbers are quite small, we have to be quite cautious about looking at any one particular year, or even perhaps a few years trended together, because we're only talking about 10 accidents a year, or perhaps 20 accidents a year. So one makes a difference, a single accident makes a difference. So there's a 3-year rolling average in there, attempting to smooth the variation out. But I think you can see there is a trend. So we can see an increasing trend in accidents, and then a bit of a dip over COVID, and perhaps a bit of a rebound afterwards. But the average fatal accident rate in the UK is about I think it's about 1.1 per 100,000 flying hours, if you just average all of that UK data. And so that's the figure which is in our annual safety review. And we could discuss perhaps the statistical significance of individual slopes and averages in that. But yeah, just keep in mind the average of about 1.1. The US rate, which is not in our annual safety review, but I've added it for this talk, I got from the AOPA Aviation Safety Institute report, which I think is an excellent publication, is in there in red, and it's a bit lower than the UK rate on average for most of the years. So they're down. The high years is about 1, and it dips slightly below 0.8 in the best years of the data. So I think the headline from that is the US is doing a bit better than we are in the UK in terms of the general aviation fatal accident rate. There's a whole debate on what might be behind that. We probably haven't got time for tonight. I certainly haven't got all the answers. Next slide, please. So sort of following on from that in our annual safety review, the branch internally assigns a taxonomy of factors for fatal accidents, and the annual safety review reports on those. So what we've got here are the factors that are allocated to fatal accident reports, and they're all general aviation ones. Fatal accident reports which were published in 2023. So that doesn't mean the accident happened in 2023. In fact, most of them are 2022 or 21, and one of them is 2018, which was the Leicester City helicopter accident, which took it was a long investigation. But I thought I'd put this in because we can have a bit of a debate about loss of control, perhaps. The big purple square there, 50% of the factors identified for these fatal accidents are loss of control, in-flight, lock, eye. And then there's a bit of a sort of mixture of other factors. So let's have a look at each of these accidents in turn, and I'll just summarize them, and then we'll turn to the loss of control events as a sort of part 2. Next slide, please. Right, so these are 5 fatal accidents reported on last year which don't involve loss of control in flight. So there was one, it was a PA-28 of Blackpool, where the flying instructor died of a cardiac failure, but the aircraft landed safely, so that's a medical factor. The gliding accident on the Cotswold Edge with a heavy landing, and a pilot suffered a spinal injury and then sadly died 20 days afterwards, which was CTOL control, that's collision with an obstacle during takeoff or landing. And a quick aside, if you perish from the results of an air accident within, I think it's 30 days of the date of the accident, you have died as in an air accident, essentially, under our regulations. There's a line in the standard 30 days. So if someone's injured in an accident and lives for 2 months and then passes away, they actually have not died strictly legally as a result of an air accident, even though it might be obvious that the injuries were linked to it. But so that's just a quirk of the regulations. Third accident there was Pegasus Quick up in Scotland, and this was a loss of control on the ground with a sort of aggravating factor of its SCF is system or component failure, and then PP's power plant. So the pilot started the engine, it went straight to full power, and the base bar was attached to the strut, so he didn't have control over the engine or the wing, and the aircraft got airborne briefly and then crashed, and he was killed. There were some safety recommendations out of that report to do with helmet safety and also seat restraints in flex-wing microlights that came out of that. Next one is a Cessna 210 on the Isle of Man, and that flew into cliffs, fatally injuring the pilot. So that was graded as CFIT, control flight into terrain. And then the last one was a Coast Guard S-92 landing at Plymouth Hospital, and the public's 2 passers-by were exposed to the rotor downwash, got knocked over, and sadly one of those people died. So that was just graded as other. This is sort of a catch-all other factor. So those are the non-loss of control in-flight accidents. Let's move on to the next slide, please, Ian. And the rest of them have some element of loss of control in flight to them. But I thought it's worth discussing because, in my opinion, they're all quite different accidents. And this is the problem of small data sets, trying to sort of have consistent labels over a small number of accidents. The top one there is back in 2018, an AW169 at the Leicester City Football Stadium. Loss of tail rotor bearing. A failure of a tail rotor bearing led to a loss of tail rotor blade pitch control, which led to an in-flight loss of control and a crash. And sadly, all the occupants on board, all 5, perished in the accident. So that was system or component failure, non-power plant. In this case, it was the tail rotor bearing, and a loss of control in flight. The next one is the Cap 10, which got stuck above cloud and then lost control in cloud, attempting to land at Exeter. A double fatality. That's a loss of control in flight. Next one was a Beccles, a CT2K at Beccles, single occupant, I think, aircraft, bounced and then stalled on the go around or after the bounce, and the pilot was fatally injured, loss of control in flight. The next one was an unexplained loss of control in flight of a helicopter during a landing, but we don't really know why. And quite often in general aviation accidents, we can say what happened, but we can't really say why unless we've got very good evidence. And in this case, there just wasn't sufficient evidence to say why the loss of control had occurred. Next one down is Newton Ards in Northern Ireland. And that was an Aeroprac Vixen that did a low pass down the runway and then pulled up at the end and lost and stalled in the steep turn and crashed. There were 2 fatalities, loss of control in flight. Second to last one is Pitt's S1S that was at Shobden doing aerobatic practice, and there was a loss of control for some reason during the aerobatic routine, and the aircraft crashed. The pilot was killed. That's a loss of control in flight. And the last one was a glider with a non-self-connecting elevator, and the pilot, for some reason, hadn't connected the elevator, and that hadn't been seen before takeoff, and the loss of pitch control in flight. So the question there from Andrew: are some missing from this list? Yes, because these are, as far as I'm aware, these are all the reports, fatal accident reports we published in 2023. So if there's a fatal accident and it was published in 2022, it wouldn't be on this list. So I hope this list is comprehensive because it forms the basis of some of our annual safety review, but that's my understanding of where these accidents came from. So, in the round, there's 1, 2, 3, 4, 7 accidents there with loss of control in flight linked to them, but they're all quite different. So, quite what you do with that information in terms of safety action, focusing on loss of control in flight, I'm not sure, but I'm sure there's many people on this on this webinar who've probably got a lot of good ideas of what we can do to try and reduce the frequency of these types of accidents. Okay, next slide, please. Getting towards the end now. So this is CAA, I think the same. So this is their annual safety review. So they do their own safety review of the accidents, but also all the incident data they have. And on the left there is key risk areas which they've identified, and the big one, the big blue arc, is loss of control. So the CAA see a similar need for safety improvement in terms of this type of accident. Next slide, please. Right, so moving on to mid-air collisions for a moment now. So after the fatal accident at Melton Mowbray, the gliding accident, the team involved in that investigation, that was including me, took a step back and had a look at over, well, it's 20 years, it actually turned out to be 21 years by the time we'd finished, of mid-air collision data in the UK to see if there are any patterns. And so what we've got here is obviously a bar graph, years along the bottom, number of collisions up the y-axis. The blue squares are GA mid-air collisions, so that's powered aircraft, GA colliding with a GA aircraft. Almost all of them fixed wings. I think there's one helicopter mid-air involved in there, helicopter with versus a fixed wing. So the blues are the sort of the GA powered, the red are the gliders, the yellows are tow planes, and there's 4 rope strikes in there, none of which were particularly bad, but they're still a collision. And the one tow actually collided with a glider, which is the one in 2018. And there's 3 unmanned air systems versus other aircraft, 2 powered GA and 1 glider. 2 of those model airplanes, 1 was a drone. And if you just look at that data, oh, by the way, the number in the circle is sadly the number of people that died in those collisions. So immediately you can see there's a lot more fatalities in powered general aviation mid-air collisions, principally because I think parachutes are not generally worn in those sorts of aircraft, and egress from something like a PA-28 is very difficult anyway, particularly if it's out of control. There was only one successful parachute escape from a powered general aviation aircraft. It was actually the Mustang at Duxford, I think in 2011, where the pilot bailed out and survived. And then in terms of the gliders, there are, I think, slightly more glider collisions than there were GA. Let's get the numbers here. So there were 15 collisions between gliders, but quite often they're non-fatal because people have bailed out. And then the asterisks are gliders involved in competition flying, which was an element of the Melton Mowbray accident. And it's slightly more than half of the gliding mid-airs involved gliders in competitions. So that was an aspect of the investigation which we followed up on. And competition flying is about 10% of the overall gliding activity, so it's sort of out of proportion to the hours flown. So those are the incident data. But in terms of rates, I haven't got a slide for this, but I'll just quote the numbers. So the general aviation mid-air collision rate in the UK, and this is all of those, there are 39 collisions there, so that's all of them, gliders, powered, everything, is about 0.34 per 100,000 flying hours. And if you compare that to the US, and the NTSB have got obviously the collision data, and the FAA have got the hours data, the US rate's about 0.09, so it's about a quarter of the UK rate, or the UK rate's 4 times higher per flying hour mid-air collisions. than they are in the US. The fatal UK mid-air collision rate, because not all mid-airs are fatal, is about 0.13 per 100,000 flying hours. And that represents about 10% of the overall fatal accident rate. So yeah, 90% of the fatal accident rate is nothing to do with mid-air collisions, but it's a small but significant factor in the fatal accident rate. Next slide, please. So to sum up, I hope I've given you an overview of the work of the branch. It's a mix of commercial air transport investigations and general aviation, and also space now, and eVTOL, things like that, with a heavy focus in terms of our resources on commercial air transport safety, but doing what we can for general aviation. The UK general aviation fatal accident rates is pretty noisy. They're small samples in terms of numbers of accidents. So one year could be quite different to another. That doesn't necessarily mean much in itself in terms of a trend. But significantly, the flying hours are down by half. Anyone who's stood around general aviation airfields in the UK for the last 30 years probably had a feeling for that, but now we see it's what the actual reduction is. And it would be interesting, I think, to look at the hours flown per pilot rather than hours flown per aircraft, because are people less current than they were 20 years ago? I don't know. As a population of GA pilots, we're aging. I think that's probably not a surprise, and that's certainly true as well for our maintenance colleagues. UK maintenance engineers are generally aging as well. Certainly true in gliding. There's a lot more work to do, I think, in terms of extracting safety messages from the general aviation data that I've presented. We need more granularity, and the branch will be working closely with the colleagues in the CAA, GASCO, and the other alphabet associations to try and get as much value as we can out of looking at GA accident data. And I'm happy to report that the branch recently hired a new safety data analyst to help us in our side of that work. He's just started a few weeks ago. In terms of mid-air collisions, I didn't really mention it in that graph, but if you look at the introduction of FLARM in gliding, it did appear to coincide with a 9-year period where we had no mid-air collisions in UK gliding. And certainly the numbers of collisions has come down quite a bit in the last 5 years or so. So I think electronic conspicuity does appear to be having some effect, which is great, because we want the mid-air collision rate to be 0. We're higher in the UK than the US. I don't know why that is. We could obviously postulate some ideas, and it's probably subject for more research and also comparison with European countries as well, to see where we stand and if there's anything we can learn from that. So with that, that's the end of my presentation. Next slide, please, Ian. So I hope that was interesting, and we've got some time for questions.
Excellent. Thank you very much. I'm just going to remove that from now. I've been making little notes on the questions as I go along. So rather than scrolling up and down all the way, I'll see how I can do this along the way. So one question here. They do jump around a bit. What happens if the aircraft actually investigate? You can read it, Afandi.
Yeah.
I'm sure
okay. So yeah. Why don't I read these out? So what happens if we reach a different conclusion to a manufacturer, or there's a let's just read the question accurately. So what happens if accident investigators reach a conclusion over an accident and the aircraft manufacturer comes up with a different or contradictory finding? So in terms of factual information, I would hope that we would never end up with a big difference of opinion over the facts of a case, but that can happen. I won't go into specifics, but we had a case recently where there was a strong difference of opinion between the accident investigator and the manufacturer to do with the way a component had failed, and there was just no agreement at the end of the day, that the manufacturer was holding one line of argument and we had evidence to the contrary. So in that case, when a report is drafted, it gets sent out for consultation processes, which is a 28-day period where any directly affected party has the right to read a draft report. It is confidential, so they can't disclose it publicly, but they get the right to read it and then send in their written comments on the report. And if there's a difference in the factual evidence, we'll try and resolve that as best we can, because there shouldn't be a difference in the facts as far as we can establish them. There may be a difference in the interpretation of the evidence and the analysis in the report, a difference of opinion, if you like. That's not unusual. And we will listen to that, but not necessarily be influenced by it. But there is a mechanism in ICAO Annex 13, if you just can't agree, the overseas agency can append their comments to the report. So you'll read a report, and at the back of it there'll be an appendix, and it'll say agency ABC from country Z states that, and then they'll say what they think, and that's it. So that's how that situation is handled. It's quite unusual, though.
It is unusual. I guess I don't fully understand this question, but maybe you have a better go at it.
Okay, so Chris says, please can you discuss the obvious scope for conflict between your remit to draw conclusions, but without apportioning blame or liability? Yeah, and you know, there is a difference there. So as accident investigators, we want to find out what happened by talking to everyone involved as openly as possible, and finding out what the safety issues are, and writing an independent factual report which gets these safety messages out, and also if there's any safety recommendations that need to be made, we'll make them. That process is separate to things like insurance litigation or criminal investigations. So if you crash your airplane and you haven't got a medical, then we would probably report on why the aircraft accident occurred, and the fact you haven't got a current medical may be completely irrelevant to the accident. But to an insurer, they would probably view that quite differently if they've got a large claim to pay out. So there are always, in parallel with accident investigations, there's usually some form of litigation potentially bubbling along in the background. And if the police consider that a crime has occurred, then there could be a criminal prosecution as well. I think the Shoreham Hunter accident is probably the most recent case where that has occurred. So the answer is these processes run in parallel, and we can't get involved in apportioning blame or liability, but that doesn't mean the legal community that don't want to do that.
Okay, another question.
So David says, how do we interface with the AirProx board? We have an inspector who attends the AirProx board meetings, but generally investigations are split pretty cleanly between ourselves and the AirProx board. So you know, if there was if the aircraft hit each other, we investigate. If they didn't, then the AirProx board investigate. And that's almost always the split. I think in 14 years at the branch, I can remember one AirProx that the branch was interested in further, but usually it's just a complete clean split between the AirProx board and ourselves, and they have their own constitution, you know, for doing those investigations, but we're separate bodies.
Another question.
Roger says, is there a military equivalent? Yeah, the answer is yes. So they're the Defence Accident Investigation branch. I think I've got that right. They're based at Boscombe Down. They're a multimodal organisation. So they used to be separate modes. So after Haddon Cave, the AAIB was founded, I think 2010. And for a few years they were here at Farnborough, so they leased some rooms in the offices here, and they started off here as the air branch, and there were separate land and marine equivalents, but they became multimodal a few years ago, and they're based at Boscombe Down. And we work closely with them. If there's a military accident, quite often, well, it's usual that an AAIB engineering inspector will be attached to provide assistance. And that happened on Saturday with the tragic Spitfire accident up at Coningsby. So one of my colleagues travelled up there to support the DAIB, and we train alongside them as well.
Okay.
Okay.
Back to
Keith says,
question.
okay, is there any correlation between collisions and congested airspace? I'm not really equipped to provide an answer to that, but I think it's certainly something which deserves a proper academically rigorous study. I don't want to get drawn any further than that. I've got my own personal opinions, but I'm not going to mention them here.
Okay.
Okay, next question. Who owns the evidence after an investigation? Some ATC recordings would be exceptionally useful for ATC training purposes. Okay, that's a good question. So in terms of physical evidence, once we're finished with it, it then reverts to the property of the owner, which is usually an insurance company if an insurance policy is in place. For cockpit voice recorders, which are subject to an AAIB investigation, those recordings are protected information under our regulations. I think it's Article 14 of EU 996. So they're actually deleted before the boxes go back to the operator because that's protected information. So I think ATC recordings would probably fall under a similar regulation. So even though they might be really useful for training purposes, they're not disclosable because they're protected by law. I think that's the case.
There's a quick question relating to your comments on age.
Okay, do you maintain any stats of accidents caused by medical issues, which may become more relevant with an aging pilot population? I think that the straightforward answer to that is no. But when an accident occurs and it looks like a medical issue was a factor or age, quite often the investigation team will go back and do a sort of wide, a bit like I did there for Midair collision data. They'll go back and do a deep dive into that area and report on that in the report. But it depends on the investigation. So, day to day, no, I don't believe we do keep stats on those issues. Perhaps we should. Next question. Andrew says, who can ground an aircraft type after an accident? Is it the branch, the CAA, or manufacturer, and how soon afterwards? That's a really good question. So it certainly isn't us. We have no airworthiness controlling function. It's the regulator. So in the UK, that's the CAA. Now we're outside EASA. So if an aircraft is deemed essentially unairworthy or unsafe, then the regulator will ground it simply. You have to have a pretty good reason to ground an aircraft because then you have to unground it again afterwards. So that it's obviously it happens. 737 Max, DC-10 back in the day, but it's pretty unusual. But yeah, it'd be the regulator, obviously working closely with ourselves in case we have unearthed an airworthiness problem through our investigation. But it's the regulator who acts.
So I'm going to chuck in a question now from myself, more of a kind of comment, and it stems from a conversation I had many years ago with a chap who's long retired from the industry, but who used to run an airfield. And he said to me something. He said, I could take a pretty good guess at the pilots based at this airfield that are going to have some kind of accident over the next year. And that guess is based not on flying with them, but purely on the attitude that I hear back from them from the fuel crew or the fire crew or whoever it is. And given your number of engineering and operations inspectors, it seems to have one human factor inspector, is that not a low number given the element?
I think it would be if we hadn't received individual human factors training. So we've all been trained up at Cranfield. Some inspectors actually have MSCs in human factors, so they are trained to master's level. We get routinely refreshed for our HF training, but we only have one specialist inspector in HF, and I'm not the chief inspector, so I am slightly constrained in my response. But I think it is incredibly important to get to the grips with HF issues in accidents because they're always a critical part of any accident sequence. and sometimes it's the most important. More often than not, it's the most important part of any accident sequence. So I certainly feel for where the question has come from, and the future probably looks a little bit more HF heavy, but quite what the shape of that is, I can't say.
Okay, last short question I'm going to pop up.
So Peter says, didn't the AAIB look at pilot or PMD's pilot medical declarations, and what are the views of the AAIB? Yeah, I think there was an investigation recently which looked at PMDs, and I just don't know what the conclusion of that was. So if I gave you an answer, I'd probably get it wrong. That's one thing about working here is there are multiple investigations going on at any one time, and you're expert on your own cases, but it's hard to stay abreast of everything at the same time, and that's something that I wasn't particularly involved with, so I can't really answer that question. Right, another question. What is the process if we want to pay a visit to the AAIB? Great question. So yeah, we are open for visits. We closed over COVID, but we're fully open again as of about 2 years ago. So the process is, if you represent a group, so we don't do individual visits, but we do group visits. So if you get a group together, it might be a group of from an airfield or a company or a university or something like that. If you write to the Chief Inspector's PA or just send an email to the inquiries address, which is on our website, addressed to the PA of the Chief Inspector. That is so basically write an email explaining who you are, how big the group is, and we can get up to about 25 max comfortably on visits, and why you'd like to come and have a visit to the AAIB. The answer will almost certainly be yes. We'll try and fit you in. We have a pretty booked out visit calendar. I think it's pretty much full for this year, but you'll be on the list and you will get the opportunity to come and visit. I know, Ian, you've been here at least once, and hopefully that was an interesting experience.
Hugely useful thing. Absolutely. We've had a huge number of comments along the lines of this one, which I haven't put them all up yet, but just to let you know that there have been a significant number of them from all sorts of very good people. And there was one that I was looking for here. I probably won't be able to find it now, unfortunately. Yeah, there you go. One from a chap called Adrian Norris. Oh. Not yet, Chief.
Not yet. No, thanks, Adrian. Thank you.
Not yet.
No, thank you very much. Thank you for the warm words. It was really my pleasure to take part in the webinar.
It's been absolutely fascinating. I hope I've got through most, if not all, of the questions there. So huge thanks, Afandi, for doing that. It's been really, really good, and I look forward over the next however many years it is for the increase in data and stuff that comes out. There's so much of interest there that could be mined. And I think that will be absolutely brilliant. Could I just a quick reminder for anybody out there who's still watching, of which I can see there are many, please, if you haven't already, like and subscribe to our YouTube channel. It'd be hugely appreciated. And there's a member webinar like this every single month of the year. So if you're not a member, this one's open to the public, as it open to everybody. If you're not a member, please join. Cost you £5 a month, which is a bargain. Afandi, once again, thank you very much. Enjoy your flying, enjoy your investigating. And hopefully we'll never meet professionally, as it were.
That's fine. Thank you.
I'd like to buy you a beer at some stage, non-professionally, as it were.
For
Brilliant.
Sure.
Thank you very much.
Thank you.
Have a good one. Thanks, everybody.
Bye-bye.